So, hello everybody, welcome to Tech Weeklies. Today we have the honor of having the man behind the original idea of Tech Weeklies, or so-called WWW Weeklies, or Frontend Tech Weeklies, whatever it was called in the beginning. Jarno, he's going to present about the Symptom Radar project, and we will have some discussion in the end and questions if we have time for that. So, Jarno, please take the stage.
Hi, everybody. I'm talking about the oiretutka service today. It's symptom radar in English. And this is a presentation about the tech side of that project. There's several people you may want to talk to about the design, the accessibility focus, and things like that. And I'm kind of hoping that there's separate presentations about those as well, because a lot of work went into that as well. But this is the tech, the nerdy tech thing. The sort of beginnings of the project, and to give you a bit of background, in mid-March, the epidemic was kind of already in full swing around the world. Not so much in Finland yet, but people were already pretty worried about what it's going to look like here. And there was really no testing capacity, and nobody had any idea of how the epidemic was spreading. So just after the lockdown started, I get a call from Bob pretty much out of the blue. And he says that Jonas had an idea. We should crowdsource symptoms from the general public. And Helsingin Sanomat was also interested in being our partner with this. And in case you don't know, Helsingin Sanomat is the largest and arguably most respected newspaper in Finland. And Bob asked, would I be interested in making this service? And yep, I was pretty interested. This sounded really exciting. Now, as it turns out, lots of people had this idea, probably because it's a pretty neat one. This is the health security director of THL, the premier health authority in Finland, or I don't know what it is in English. But they were asking on Twitter whether somebody could make this, basically. And this was slightly after we had already started work. So in the following week or two after this tweet, it seemed like every day some hackathon somewhere had produced a proof of concept implementation of this. But our solution was to be slightly different. We were operating off the assumption that this requires a lot of data to be useful, and the sort of build it and they will come mentality will not be enough. But we were partnering with Helsingin Sanomat, so we would probably have pretty good synergy with them. And so we laid up some objectives for the project. First of all, we wanted to be absolutely transparent, so people would trust us with their data, and somebody can independently verify any of our claims about how we do things. So it has to be open source. We want it to be by the public, for the public. So even if we couldn't figure out something interesting to do with the data, somebody else could. This was not patient data, but still very personal health data. So we wanted to be extra careful with everything. And we also wanted to steer clear of any GDPR triggers, even if, as I learned, media has some exceptions to this, but still. And this had also one side effect, for example, was that using off-the-shelf CAPTCHAs for proving that you're not a robot would actually be slightly problematic, because they usually collect a lot of data from you. The reCAPTCHA version 3 by Google is particularly creepy about this. Security, kind of the same thing, in that any security incident we might have would compromise this privacy, and that would not be good. For scalability, we were targeting the front page of the highest traffic websites in Finland, so traffic would be very spiky, and also we would need to be able to take the load that you get from such visibility. Cost effectiveness, then again, when we're not on the front page of some publication, it'll be a lot quieter, and we don't want to pay for resources that we don't use. Performance, especially related to front-end performance, this needs to load fast, even on crappy mobile devices and networks. Accessibility, we were expecting users from all walks of life. There was also the possibility of THL being involved. So we wanted to make sure that we would be up to spec for people with disabilities and so on. And again, the CAPTCHA was an example of something that was kind of affected by this, because even for people without disabilities, they are annoying, and you always lose some users who get frustrated with their CAPTCHA experience. Then dealing with abuse. An open forum on the internet can attract spam bots and script kiddies. So we had to have something in place to deal with that. And time to market, because kind of everybody and their mom was making one of these. We needed to get this out fast so that it remained relevant. So in this talk, I'm first going to show kind of what the service looks like from the outside. Then we're going to take a look under the hood, and then at the project setup, like how is this, where is this hosted, and CI/CD stuff. Then we're going to take another look at the objectives that I previously covered, like how did we meet them, and finally there's some time for quiet reflection on how the project went. Right, so the external view. The data collection part, the embedded site, is the entry point for data and for most people using this system. A participating news site will include this on their page, and then people can go and look it up and then click on this participation button, and then the thing expands to a full form with a bunch of pretty straightforward, mostly multiple choice questions regarding what kind of symptoms you have. And then in the end, you will submit the form. And this is the main output channel. You can, if you're a newspaper, you can embed one or more of our sort of results widgets, which will show the data that we have gathered in various interesting ways. And then there's also the standalone site that we have, which is just to make sure that you can access all of this even without going through some newspaper. There's additional options there, like you can play around with the data a bit with some basic filters, and you can look at the data using tabulated views instead of the map view. You can find a bunch of other neat views into the data set from there as well. Oh yeah, and finally, the standalone site also allows you to participate into the questionnaire, so that you don't have to figure out like in which article the latest the form would be included, and you could just go to the site directly. Then we have an open data site where we publish all of our results. This is actually the site that we dog food ourselves, in that all of the visualizations that we offer as embeds, and also all the visualizations and tables and whatnot that we have on the main site, they actually pull their data from here. And one cool thing about this data site is that if you go there, the index document actually has content type of application /JSON, because it's meant for nerds, so they can surely read JSON. But yeah, I thought it was cool. You can also just throw high charts into a JS fiddle and pull in some data from the data site and start doing something interesting that way. Right, so that was the external view. Now let's take a look under the hood. This is the high-level architecture. We'll go through this one by one, so you don't need to squint. First, here's the thing that's embedded to the news articles for data collection. And you read that right. We used jQuery in 2020. And as it turns out, you actually can build things for the web without React. And as we'll see later, it can contribute to pretty great performance. Who'd have thought? But also, I hate fiddling with Webpack configuration with a burning passion. So we ended up using the Create React App zero config Webpack setup, even if we didn't have React anywhere in the project. You still get all the cool stuff like the production bundling, the library loading web server, TypeScript support, and so on. Once the web assets are built, they are uploaded to S3, and there's CloudFront in front of that for performance. The static files are configured to stay on CloudFront for effectively forever, because they have cache busting hash in the file name, so that when the file changes, the hash changes so that it gets invalidated. That's for static files. Then for dynamic files, such as the index HTML, which then links to static files, they are cached only for some seconds, just to take some load off S3. But that's to make sure that when we do a release, then we can do it almost immediately, even though the static files, which make up most of the weight, are cached forever. Localization is handled build time, meaning that there is a separate index file for each language. It's done using very low-tech approach, meaning low-template. It worked great. Again, for performance, this is pretty great because there's exactly zero overhead during runtime. For the localization, it's just you load the file and everything is already there. The whole infrastructure for this front end is packaged into a Terraform module, which you can find on the Futurice GitHub. I recommend you check it out. It has a lot of goodies baked in, like DNS management, HTTPS certificate support, strict transport security, preventing direct access to the underlying S3 bucket, basic authentication, custom headers, an extensively documented content security policy, which you can copy paste, and like I said, all kinds of goodies. Go check it out. Then the backend API, it's a Lambda function behind API gateway, pretty standard issue. It's built from the same TypeScript codebase, just with a different entry point. And one interesting thing to note is that we used IOTS for validation. It's quite nice because you can define your models once and then make use of them both at compile time as TypeScript types and at runtime as validators that produce objects that conform to those types that you have defined. The Terraform module for this is also on GitHub, and what it does is basically takes your JavaScript bundle and makes it available as a Lambda and configures all the boring stuff for API gateway, and basically just hands you a URL with a custom domain and HTTPS support that you can call to invoke your code. Then the abuse detection service. Now, when a request comes in, we grab its source IP and the user agent and forward it 4 headers, and we call that the fingerprint of that request. Then immediately after, we put those values through a one-way hash function with a secret salt/pepper string included, so it can't be reversed, so that if you look at the hash, you cannot know what the original IP or user agent string was. Those are then stuck into DynamoDB with a time to live for each key of 24 hours, so that the database doesn't balloon forever and the old keys sort of like just fall off the database when they expire. And then using that information in DynamoDB, we calculate an abuse score for the incoming request by just looking at how many times we have seen this same IP and this same user agent over the past 24 hours. Now, when we look at those, we don't know what that IP or user agent was, but we know how frequent that has been. And then that is stored along with the response so that it can later be used to then assess the credibility of each response. Then the actual storage of the responses, it's pretty simple. We just store them as JSON in S3. The keys for these individual JSON blobs are designed so that you can partition them by time if you need to optimize things later, because we only ever append things. So old answers can never change. So it would be fairly easy to just do rollups and just store like pre-processed stuff for a certain prefix. But we actually never got around to it because it didn't look like we needed it. So, but it's there if we need it later. Then the backend worker, it's another Lambda built from the same code base. This is periodically invoked, so it's not available as an HTTP API. It's just basically a cron job. It runs queries on the S3 bucket with Athena and stores the results in another S3 bucket. Now, Athena is it's a fully managed query engine for data in S3. You can basically run SQL queries on your data that is in S3. And with Lambda, what you do is you pay for execution time, but with Athena, you only pay for the data that your queries read. So what the worker does is when it kicks off, it starts all the queries in parallel, and then it just sits back and relaxes and waits for those queries to complete. They then complete at the same time. It collects the responses and stores them as JSON into the other bucket. You could optimize this, of course, by just like kicking off the queries and then terminating the Lambda immediately, and then run it a bit later to just collect the results. But again, we didn't really bother. The Terraform module for this is also available in GitHub. It also just takes your JavaScript bundle and a cron expression that you give it and turns it into a scheduled Lambda that is invoked automatically every once in a while. Then the open data site, it's pretty simple. We just stuff the query results in there, update the index file, and that's pretty much it. The one thing that's maybe different is that it has a fairly liberal course policy, so that any data that is there can be fetched from any other site. For example, I had the example of using a JS fiddle that pulls data from there. It is made possible by the course policy. And the same Terraform module is used here because, it's a site full of static data. So, yeah. And then finally, the main standalone site, It's a full-blown React single-page application with D3 localization, client-side routing, all the bells and whistles. Unsurprisingly, it also uses Create React App for bundling, and it uses the same caching strategy on CloudFront, where we have the static and dynamic files differently, having different cache control headers. Also uses the same Terraform module. This time it makes use of one of its features, which is supporting client-side routing while still making reloads from the server possible with the same URL. Like when you have client-side routing, when you navigate around a page and then you hit reload, it's actually somewhat complicated, because then you need to be able to serve the same index files, but then have the JavaScript take over the routing. Anyway, it requires some participation from the server, and the module supports that fully. So it was neat. There is another Terraform module here as well, which is a domain redirect one, which is just a simple but fairly common thing where if you don't want to host your site at the apex of your custom domain, you need to redirect web clients to, for example, www.whatever.fi. So yeah, there's a module for that as well. And yeah, that's the whole round. So here's again the architecture from afar. There's also some dashboards mentioned in the bottom right corner. I kind of forgot to cover them, but you'll see some screenshots of the dashboards. Right, so that was the sort of inside look into the architecture. Now a couple of words about the project setup. Well, yeah, it's a monorepo on GitHub. This, again, followed the typical evolution that I at least have, where if you're building a thing that has a front end and a back end and maybe some support infrastructure, you first start by thinking that, hey, these actually are separate things, maybe slightly different technologies. They go into different repositories, but then you end up wanting to release them at the same time because it's just convenient, and you don't want to figure out like how to pull, I don't know, library code from the other repo, or you need to share some code or something. And yeah, so you end up wanting a monorepo with a bunch of separate packages still, so that you have one repository with folders that each of them contain like a package JSON or something. But then you end up wanting to share like some TypeScript definitions or some library code with them. And then you tear your hair out with TypeScript include paths and whatever. And at least for me, usually what it ends up kind of like coalescing into is a monorepo with a single package .json at the root that just has different npm scripts for starting the different projects at that repository. I'm actually quite fond of that setup, and it also kind of accidentally, but also on purpose, takes care of other things like having almost the same, but not quite the same versions of TypeScript across your different sort of sub projects. And if you want to do like npm run lint and get compiler results after some refactoring from all of your sub packages at the same time, it actually ends up being quite complicated if all of them have separate packages. So yeah, this is a good setup, I think. Then on the repository side, this is effectively our CI/CD pipeline. It's implemented with GitHub Actions, which are just lovely. If you're not familiar, you just define a YAML file in your repository, and then you can run custom commands at various events, like when somebody pushes code, or somebody merges to master, or somebody creates a release on GitHub. So we don't have any Git flow or anything like that. We just start PRs from master. They end up back in master. I, again, quite like this setup because it's very simple, and simple is good. For each PR we run through GitHub Actions, we run the full QA suite, meaning lints and tests and whatnot. Then whenever a PR lands in the master, we do the same thing again. And then if all of those steps are successful, then we deploy the embed site, the standalone site, and the backend API and worker lambdas to the dev environment. And then releases to production environment are handled by creating a release on GitHub, which also triggers a GitHub action. And yeah, that's pretty much it. The only thing that kind of was left undone in the rush was usually it would be better to, instead of rebuilding for production releases, would be to promote what is currently on dev, or whatever your QA environment staging is called. So instead of rebuilding, you would promote whatever is on there to become the new production. But oh well. Gotta go fast. Right. So then that's pretty much the implementation covered. But then did we reach our objectives? Now, I tried to kind of assess that for each of the things that I listed. For open source, it's pretty straightforward. We were almost from day one open source. We started off with a private repo, but then we made it public pretty soon. You can go take a look. I'll include the link later as well. Then open data is mostly there. All the various aggregates that we have are available for anyone. The full data dump, sadly, is still stuck. We're waiting for permission to release it, as some higher-ups are getting cold feet about releasing data that is, even though we spent a lot of time and effort in figuring out all the privacy preserving angles, it's still kind of health-related data, and yeah, it's a bummer. But still, I'm also really proud that there's no mystery meat in our data pipeline. Every data set that we use, such as population information or the geography that our maps use, it's also included there. So everything that we use to produce our data is available from there. And it also includes information on how it was obtained. So it's not just, this is the population of Finland, and you have to take our word for it, but it has the links to the relevant Tilastokeskus data sets and whatever. Then for privacy, well, first of all, no analytics are collected from any of the front ends. This is pretty novel, I think, in this day and age. The analytics collection of any of the embedding pages, like how news articles are full of creepy trackers, they cannot reach into the iframe that hosts the actual data collection. So, I mean, they will know that you went to the page, but what you did inside the iframe stays in the iframe. We don't use any web fonts to prevent snooping by Google Web Fonts, for example. They have had some bad visibility with regard to that. Then, as I mentioned before, the unique IDs of participants are put through a one-way hash function that includes a secret salt/pepper. That's done before they are stored. So it's done before they are even stored, as opposed to doing it when the data goes out somewhere. So we don't ever store the plain text once it's effectively thrown away. Any potentially identifiable metadata, such as IP addresses or HTTP headers, we never log those on the back end, at least before they are obfuscated. The same goes for the response itself. When we receive a response from the client, it's not logged before we take care of all the meticulous obfuscation steps that we have. Then for very small places in Finland, just having one answer from there could kind of indicate who it was. So for that reason, if we know that some area is very sparsely populated, we combine those areas with their larger neighbors. The precision of timestamps is intentionally reduced so that you cannot correlate that with anything else. And then I mentioned the abuse detection thing that uses some of the metadata, but it uses that in an obfuscated manner.
What are you using to determine population density?
It's from a Tilastokeskus data set.
Okay.
It's on the open data site. You can go look if you don't trust us. For security, we had the pretty standard third-party security audit before go live. I'm happy to say that there's not a lot to report. The things that are listed there, the API rate limiting, for example, I think they put in something like 250 requests per second, and our standard Lambda rate limiting didn't even kick in at that point because it was something like 500 or something. But it's there. It was just really high. Then the other thing was the timestamps submitted by the client. They could be altered, of course, because you can never trust what the client gives you. But internally, we actually just ignore the timestamp that the browser gives us, and we generate it again on the server side, precisely for this reason. The one thing that was actually a good call was that we were missing the HTTP strict transport security headers for our API responses. So we did add those before going live. Then for scalability, on the right, you can see how a typical news article being published looked like for us. Charts going up pretty fast. And the front pages of the top web properties in Finland definitely generate a lot of traffic. But if you make sure that you can handle it all with static content, it's basically nothing. And while we do get a lot of eyeballs when an article goes out, it's only a tiny fraction of those people who actually participate. So that was fine as well. The cost effectiveness, then as you hear people talk about the cloud, you're supposed to be able to pay only for what you use. Now, this doesn't apply in general, but it does apply to the services that we used. So if it's a busy day for us, the daily costs for running the service were something like $5. And then if it's a slow day, it was something like $1. And the data processing costs on the data pipeline, because Athena is run sort of out of band by the backend worker, then you can pretty much determine how much you want to pay for that because it's constant. It doesn't depend on the amount of traffic that you're getting. And here's our API traffic for comparison. The peaks align pretty perfectly with the peaks in the daily cost report. So if you toggle this quickly enough, you can probably see that. Performance for the embeds, because of the choices that we made, such as skipping React in favor of jQuery and doing localization build time, we get a perfect Lighthouse score without even trying. And I mean that. I just thought I'd run it one day and see what it says, and we never really optimized anything. So that shows you how it goes a long way to keep things simple, I suppose. The standalone site has a lot more libraries and bells and whistles, so it gets penalized particularly by how long it takes for it to render the full map of Finland on the landing page. But we could probably optimize it quite a bit. But again, we never got around to it. For the backends, here's our basic performance numbers. Something quite interesting are the bumps in the average response time during nights. But the reason is quite obvious once you start thinking about it. These are the dreaded Lambda cold starts in action, because at nighttime there's very little traffic, very few people participating, obviously. So the Lambdas are going to be asleep, and the next request that comes in is going to wake them. Here's actually a great site that was just, Tom shared it today on Slack, and the numbers actually match pretty closely what you see for Lambdas in general. So I was quite happy to see this, in that it wasn't something funky that we were doing. It's just how Lambdas usually are. Now, these numbers are okay. Everything depends on your use case, as always. For our use case, these numbers were actually great. I was really happy. But if you're building some kind of, I don't know, high frequency trading thing where the speed of light like literally comes into play in your optimizations and where you want to set up your office, then this would of course be terrible. Everything is a trade-off, and for me at least, the peace of mind that you have with a fully managed platform like Lambda it's an amazing value proposition. And as you saw before, our traffic was very spiky and sometimes unpredictable. But basically all you need to do with this stack is sit back, relax, and look at graphs as CloudFront and Lambda do their thing. So I quite liked it. Then also, this is a no-brainer when you consider the architecture, but I just wanted to include it. Because if you were running these kind of queries every time a client asked for that data, you'd be hosed. But with this setup, it's nothing. Accessibility, anyway, it takes a lot of work. And one thing that I always kind of have to fight with is the feeling that you have to make less pretty things. You have to, I don't know, live with all the focus rings that people want to hide the first thing some designer shows up. Not our designer, though. Killian was amazing in that regard, but still. And I also wanted to give a shout out to Futurice for helping us with this. He's a super capable person in this regard and other. So go talk to him if you have accessibility woes. These are the scores for the embed sites. I think the only minus points that we have for accessibility were some contrast ratios for some fonts or something. These are the numbers for the main site. But it's for the table view, so it doesn't have the map of Finland, but just the tabulated data set. So it gets a perfect accessibility score. This is not an accident, by the way, whereas like the performance score for the embed is pretty much an accident and just a byproduct of what we decided to do with regard to the architecture. But this is definitely not an accident. Lotta and others spent countless hours fiddling with things and to get them just right. And yeah, this is the accessibility score for the map view. I think the minus points that we got there were for some missing roles or something, so that something in the SVG of the map of Finland had to be annotated correctly or something, but it's still a pretty great score. Then one decision that I was really sweating over was how we would deal with abuse. But as it turns out, we never really saw anything too suspicious, and I suspect that it's what it says here in the slide. We're probably a fairly boring target for spammers and script kiddies. For the vast majority of responses, the same IP had not been seen before during the 24-hour window. For about 1,000 responses, it had been seen once, and so on. So nothing in this screams that there's some kid in some basement running curl in a loop. So it looks clean. Then here's the same for the user agent, though this is slightly more interesting in that, again, you can see that most of the user agents had never been seen before. This is kind of expected because there's a lot of noise in user agent strings, and we have a very diverse user base. But the long tail is also interesting in this one because the record holder is an answer where the same user agent had submitted 168 answers within the same 24-hour window. Now, even with this, it's pretty safe to assume that it's just some very popular privacy-minding browser. It could be, I don't know, iOS Safari or something. But all in all, everything looked fine here as well. And frankly, I was slightly disappointed to not have the actual user agent strings to look at because it would have been tremendously interesting. But again, it was the price that we paid for locking down the privacy-preserving properties of this approach. And then finally, the forwarded for headers were extremely uninteresting. Suffice it to say that most participants didn't even send one, and when they did, it was unique to them. Then time to market. Well, we managed to go from nothing to production on the front page of Helsingin Sanomat in 10 days. And while there were a lot of people sort of buzzing around the project at the time, only 2 of us were actually pushing code at that point, me and Lotta. So I'm kind of proud of our velocity there, getting the project off the ground. Now, of course, later, lots of great people joined us to help with the code. But yeah, in the beginning, it was just me and Lotta. And yeah, then at the end, looking back a bit on the project, what worked? Well, I was very, very happy with the hosting setup. It has horsepower when you need it, and it's very cheap when you don't. And you generally don't need to do anything with it. It just works. I was also very happy putting some of our Terraform modules to use. They definitely allowed us to go really fast in the beginning because they set up most things for you, and you just have to plug them into each other. And then I don't know, kids these days might look weird at iframes, but they still remain the primary workhorse of isolation on the web. As expected, we had 0 issues with the hosting sites interfering with our styling or JS because they simply cannot reach into the iframe. IOTS is also a great tool for this combined build time, runtime validation thing that I mentioned. I suggest you check it out. And then going with simpler tools than React was the right choice, even if it might seem like people will point and laugh at you if you don't use React for something. It's still possible to use something old or even unfashionable. It served us well, at least. GitHub Actions are lovely. And I don't know, personally, I think that the days of using Travis or Circle CI are kind of numbered because why bother? It's just so nice. Once again, I made the same journey to a single package Monorepo. One day I will learn and start directly from there without first attempting splitting to several packages. The pre-built translations for the embed also ended up working wonderfully. They are really simple and really performant. So thumbs up for that. And yeah, I was really happy with S3 and Athena, especially in the beginning when we were really rushing to get this out. It's so easy to just start shoving stuff into S3. And then when you go look at it with Athena, you have the full power of SQL for querying it. And yeah, one good thing about that is also that it, again, costs exactly nothing when you're not using it. So you have a lot of control there. Here's a reiteration of some things that I was kind of proud of there. Possibly the most interesting ones for myself were the decisions around privacy and how we lost a lot of info into who was using our service and how. But again, in this day and age, it felt like a worthy sacrifice. And also how we decided to not try and prevent abuse, but rather detect it and then fix things later if we need to. And even then turned out we didn't, which was really the best possible outcome. Then some things that I'm not totally happy about. The build it and they will come thing really applies to open source. You think you've made something cool, so surely others want to contribute as well. But of course, what you usually get is either nothing, or at best, you get some people opening issues to complain. This wasn't really news to me as I've been an open source maintainer for a while, but some people were slightly disappointed. Then the simplicity that we gained by just using create React app also backfired a bit in that it makes some assumptions about your repo layout, which aren't exactly compatible with having more than one such project in a single repo. So there was some hair pulling involved, but now it works quite nicely. So if you want to set that up, go look at this repository. And this is not really a technical thing, but because we decided we don't want to collect emails or any contact info from people, we couldn't really remind people either to come back and update on their report on their updated symptoms. So as a result, without kind of constant media visibility, there's very few people participating in this. When we're on the front page, there's a ton of people, and when not, there's almost nobody. But then again, the need for this project has also kind of faded a bit, in that the testing capacity for COVID-19 has gone up significantly in Finland, and other tracking methods are being devised, one of them being developed quite close by. Then if we had more time, I would definitely have set up a continuous lighthouse scoring for PRs, like I've had in some other project. So you get feedback right in the PR if you introduce an accessibility regression, for example. We had a couple of those because it's pretty easy to just, I don't know, not notice. And if you only have people occasionally running Lighthouse manually, then it's easy to forget. And finally, S3 and Athena, even though it's nice and simple and lovely, it can get expensive if you don't bother optimizing at all and you just keep it running the same queries pretty frequently without any partitioning or anything. Yeah. So thank you. This was, of course, a team effort, and I want to thank everybody who took part in this project. Here's the people who contributed code at some point. I will take a break so that you can look and appreciate at all the names on this list. And then here's the people who helped in other ways by being helpful on Slack, by being the PM, by helping us with data science questions and so on. But yeah, that's it. If you have any questions that you want to shoot now, you can go ahead and do so. And I will definitely be around on Slack also if you want to ask questions there, which might be easier, but yeah.
Thank you. Great presentation. So do we have questions here? We have some time for questions. Maybe I can shoot one question that I have. You mentioned that you weren't able to follow up because you didn't collect any emails or anything. Would it be possible to somehow make a separate service that would store the email addresses, and then you would have some kind of hashed email address that you could then use or something like that? Do you know?
Yes, it was one of the approaches that we considered, and it was actually the thing that we would have done if we decided to go this route. But it was decided that we don't want to do that at all, because you can always kind of do your best to separate the data sets, but in the end, it would be quite possible that something ends up leaking somewhere that could be used to correlate the two data sets. And while definitely doable if you do it well and be careful, we were in a rush and didn't want to take our chances. But definitely something that I hope we would have done differently. It's not a technical decision as much as it was a political and, I don't know, GDPR ass covering and so on decision.
Do we have questions from anyone in the Hangouts?
Well, I could have one. About there was mentioning of the good old jQuery being used there, so there was probably a good reason for that, but I was just wondering that why not go full vanilla JavaScript instead, or was there something that the jQuery was really helpful with?
One tiny reason was honestly just the novelty factor of using jQuery, but the biggest reason was that we had, like I mentioned, a very diverse user base. So if we were able to see the user agent, I would bet that there would still be a lot of, I don't know, IE8s and whatever you could find in there if you really looked. So given the time constraints that we had, it seemed like a better idea to just take that tiny penalty that you get from the jQuery in the bundle size to like risking that it doesn't work for everybody. I definitely, like, that is something that I would have done. Like, if we had more time, the first thing that I would have done is use a different build of jQuery that doesn't have everything, that has only the things that we need. And the second thing would definitely have been to just get rid of it entirely. But yeah, we had to pick our battles.
Fair enough. Sounds very reasonable.
So thanks for the presentation. It was very interesting. Do you know if people have used the data, even though it's only the aggregated data at the moment, like outside, I don't know, the oiretutka itself?
Yeah, there's the news companies that participated in this, namely Helsingin Sanomat, Ilta-Sanomat, Iltalehti, MTV Uutiset, and Yle Uutiset. All of them have had private access to the anonymized data set, and they have made some of the things that they have included in their articles themselves. So it's not like all of it ours. And then there was some startup that wanted to use that for something that I forget what it was. I don't know if they ever got the data set, but no, as far as I know, that's like it has only been used for this kind of media reporting. Personally, I do think that publishing the entire open data set would be valuable, especially because the global pandemic is something that will be analyzed to no end over many years to come. And it's very likely that the most useful use case for the data set comes years after, when somebody is finding things like how did things progress at this point and correlating with some other interesting data set. And yeah, it might be that it's just not yet.
Yep, cool. Yeah, I think that's another question. Have you thought about how do we archive the data for,
well,
like,
yeah,
no one just goes and accesses an S3 bucket
yeah, that's a fair point. The data has been backed up, but it's only been backed up to a separate S3 bucket. So I don't know, that could also go bye-bye at some point. The sort of archival strategy for the project is to simply unplug all the active bits and just leave the open data site running, because it's just CloudFront and S3. So if you don't do anything about it, it just sits there forever, not really costing anything. Other than that, nope, I don't think there is. I'm pretty sure that Hesari has some vault somewhere where they could put this, but I don't know. Okay, Mikael has a question on the comment section.
Yeah.
So the question is, given the privacy-sensitive nature of the project, did you employ any special precautions in the development practices of the project, day-to-day stuff? Not really, to be honest. The like transferring AWS keys and everything was done pretty traditionally in sending like either an encrypted mail or SMS or something. And we took a look at NPM audit results, but it's not automated, so it's not really worth that much. I think the short answer is no. But I would also have to say that because of the design of the architecture, there's also not that much that we need to sort of protect ourselves from, because even in logs and things like that, there is like most of the data is scrubbed before it hits any log or anything. So we found it quite safe.
I have one more question. So you said, you showed the project setup and the deployment pipeline and stuff like that, and everything was quite simple and small in a sense. So why didn't you do like continuous deployment? Deploy every time somebody merges something to master?
We did, so I probably communicated it less than well. The thing is that whenever something is merged into master, we deploy that, but only to development. So the development environment was password protected, so it like the only people having access were people in our sort of inner circle. If the question was why didn't we just release to production on every build?
Yeah, that's what I meant. Yeah.
Right, yeah. I don't know. If you have good enough kind of automated QA, then by all means you can do that. And in some projects we have, but usually I do find solace in having the sort of manual step involved. Like clicking on the draft or release button on GitHub is not a lot of work to do. So it's kind of nice to have the tradition of somebody doing that manually, because then you get the opportunity to shout out in the channel like, hey, can people take a look at this? And then maybe somebody opens the page up in their iPhone because you have only been looking at it on the desktop browser and find something. I have found it to be helpful, but definitely the downside is that sometimes you get laggy days or weeks when nobody just bothers to click the release button. So yeah, it's a trade-off.
Yeah, but I agree with your point. All right. If we don't have any more questions, then I think we can end the session. I can stop the recording now. Thank you, Jarno.